Welcome to Practical Python. In this video, we're going to take a look at Treasury rates and compare them to SPY to see if there's any correlation that you could use potentially for the purposes of trading. Now, in this set of videos, we're going to use Jupyter Notebooks in order to run our code. And so you need to have that set up already, and I recommend using an Anaconda install, which includes a lot of the other resources we'll use throughout this program. So with that being said, let's go ahead and get started. If you follow the link in the description, you will have access to these files right here. We have our Jupyter Notebook file, and then we have two data files that I will show you how to get access to as well if you want to get your own data, or you can pull them down from our Google Drive. So to get started, we're first going to import some modules. As we're getting going, the first module we're going to need is pandas. So we'll go ahead and type import, which gives us access to that module, and we'll say pandas as PD. So that's a common way to import it, is now we can reference it with PD instead of its entire name. Okay, to run a box in Jupyter Notebook, you'll go ahead and hit Shift Enter, and we can see that that code has now run. Coming down to the next section, what I want to do is go ahead and grab the data that we want to look at. So I'll bring up Google and we'll type in Treasury rates, and we can scroll down. We want the actual government resources, so we'll click this one right here. If we read through, we can see Treasury par yield curve rates, and this is the data we want. We can see that it is published at 3:30 or approximately 3:30 every day. So if you want the current day's data, you need to pull it after 3 p.m. Eastern time. So if we come here, we can actually see the data, and here is a data of our current month. We can go ahead and select whichever data we want. So for the purposes of this, we're currently working with 2021 data, so it gives us entire year's worth of data in a single download. We click apply, then you can simply click download CSV, which will download the file for you. If you want, you can grab that data right here in terms of our TRates or Treasury rates for 2021. With that file in the same location as your current Jupyter Notebook, we can go ahead and bring that data in. So to bring it in, we're going to use our pandas library to accomplish that. So we can simply do, we'll call this a Treasury rate data frame is going to be assigned what we pull from pd.read underscore, and then we're looking for a comma separated value table, and we will pull our TRates 2021.csv. We'll go ahead and hit Shift Enter, and it loads the data for us. Now, if we want to go ahead and take a look at that data, we can go ahead and simply type in Treasury rate data frame, hit Enter, and there is the data. So we can see we have all the dates, and we can see here is December 31st with the 1 month all the way up onto the 30-year data. Now, this isn't exactly how I want the data to be presented, so what I'm going to do is I'm going to slice the data. And to do that, we're going to put square brackets at the end, and we're going to do 2 colons followed by a -1. We'll talk about slicing in a different video, and I'll put that in the link below once I've created it. But essentially, we want the data to be stepped backwards negatively, and so we put a -1 at the end here. Now when I run it again, we'll see that the data starts at January, and it counts up or increases down to December 31st. So this is more useful when we pull in our SPY data later on in order to compare them. So how can we plot this? Well, we're going to use the Plotly library, which is included in the Anaconda install. So we'll go ahead and type in Plotly, look at Python, and pull up the graphing library. We're just going to plot lines for now so we can see how each of those lines change over the course of the year. And then there's a couple different included portions of Plotly we can utilize. So I'm going to scroll down. The example that I want to utilize is line plots or different line modes. What this allows me to do is I'm going to import this graphic objects or graph objects, and then you'll create a figure and then add each of the lines we want to our figure. So we'll come back over to here and we'll go ahead and add that. So we'll import plotly.graph objects as geo for graph objects. Now it's imported, let's go ahead and try to plot this. So to get started, let's go ahead and create our figure. So our figure is simply going to be fig, and we'll assign it the value of graphic objects dot a brand new figure. Okay, so we can see that worked. Now I want to go ahead and add the traces. So to add a trace, I'll create a trace. So we'll say trace, and we'll say that our first trace is going to be a graphic object dot scatter trace, and then we have to provide our x and y data. So the x data is simply going to be our Treasury rates data frame, and then I want to pull a specific column, which along the bottom I want to be dates. So we'll go ahead and specify dates there. Then our y data is going to be from our same table, Treasury data frame. And let's look at the next thing we want to have. Well, let's say we want to display our 1 month rate. So to do that, we'll do square brackets, and then inside quotes, we'll do 1, there's a capital MO like that. Then we can also give it a name, so we can break out the different lines, and we'll say that name equals 1 month. So we got a little error here. We'll go ahead and troubleshoot that quick. It doesn't like dates because the column is actually called date. Alright, we'll go ahead and add that to our figure. So to do that, we'll say fig, which is our graph object right there, dot add trace, and then we'll go ahead and add our trace. Once we've done that, we can go ahead and do fig dot show, and this will allow it to appear. So now we can see we have this cool plot down here. And what I like about Plotly is it has some built-in capabilities right off the bat. So what we can do here is we can maybe zoom in and see, oh, I want to look at this specific chart. And it zooms in and scales correctly along the side and the bottom, so we can actually see the data in an easy to read state. Now this is great, and we'll go ahead and add some more lines. To do that, we'll just go ahead and copy this, paste it, maybe I'll call this trace 2, and we'll say once again we want date, but maybe we want the 1 year data. So instead of 1 month, we'll do 1 year. And then of course, to appear in our chart, we have to add it. So we'll do fig dot add trace, and we'll add trace 1. And trace, call it trace 2, so we'll stick with trace 2 right here. And there we go. Now we can see that both those lines have appeared in our chart. Now this can become very inconvenient depending on how many lines we actually have. So what we're going to do is we'll create a looping method in order to accomplish adding all of the lines to our chart, and then we can make them visible or devis them as we want to see just what we want to see. So to do that, it turns out that our data frame has a way to access all of these columns from up here. So to do that, what I'm simply going to do is comment out some of this code. And to comment out in Python or Jupyter Notebook, we simply just add these pound signs right here. Okay, and I'll bring this one back later on, but for now we're not going to show any chart because I haven't added anything to it. So in order to see the different columns of our chart, we can go ahead and say Treasury rates data frame dot columns. And if we do that, we can see here is a list or a container of all of the strings for the individual columns. Then taking that, what we can do is put that into a for loop. So we can say for, and we'll say maybe column in our container here, and then using this variable column, for now let's just print it so we can see that we're iterating through the data we want. And there we go. So there is the data vertically printed. However, we don't want to plot the date information because that is along our x-axis. So what we're going to do here is we're going to once again use that slicing term to grab only the data we want. And this is at an index of 0. So what I can use is square brackets and say I want to start at an index of 1 all the way to the end. So now when I run that, we get 1 all the way up to 30, or 1 month to 30 years. So using these same concepts from above, we're going to create a trace. So we'll say that a trace is going to be a graphic object scatter. X data is our date, and then our Y data is actually going to be from our data frame at our current column for our loop. And the name, we'll use the same column as well. And then what we'll do is we'll go ahead and take that trace, which is just for that instance of loop, and we'll do fig dot add trace. And the trace we're going to add is the trace we just created. So as this loops through, it's going to add every single column into our figure. Now I don't need to print them anymore because I know what I should be getting. We'll go ahead and add this figure back in. So now when we run it, we have all of that data displayed nicely for us to see. Now in the next video, what we're going to do is we're going to start bringing in our SPY data with the goal of eventually comparing them. So we can see, oh, maybe there's a drop or an increase in price in SPY, and then how does that compare to these rates here? So maybe we can see that there's a price jump right here. Well, how does that impact our Treasury rates, or what's the comparison there? Okay, well, so with that, come back for our next video. If you want to make sure you don't miss it, you can go ahead and subscribe, like the video as well, and look forward to seeing you for our next lesson.